Integration by substitution. Suppose I ask you for the derivative of something like, what did they have? That. Then you're going to use the chain rule, which is what substitution's about, to go 7 times the brackets to the 6th, multiply by derivative of the inside, which is 2x. So then what if I ask you for the integral of that expression?
So without the 7?
And you're going to go, well, this bit is this bit, so I've actually got 1/7 of this is the key. I'm probably going to get this wrong a few times, but I'm going to try. This is the derivative of this. And that's the pattern we're going to look for. The substitution rule says the integral of some function of u times du dx is the integral of f of u du. Maybe I'll write that sideways actually. It might be better. Make a nicer thing. And this is the rule we use for substitution. This thing in here multiplied by its derivative. When you see that, you can change what you're integrating with and get a much simpler integral. If you like, you can think of this as cancelling out the dx's. We're not actually cancelling them out because, again, they're really limits as they approach 0. But algebraically, it's basically the same as going this cancels out and I'm just left with du. This is where it really starts to matter that you know what variable you're integrating with. Really important. Let me give you some examples. E.g. integral of x squared x cubed plus 7 to the 9th dx. And you're always going to look and go, oh look, this is the derivative of that. That's your key. Always look for that. I'm going to write this slightly differently. Now let me show you 2 ways to write it. This way goes, let u equal x cubed plus 7, then du dx is 3x squared. And over here I'm going to go, this is the integral of u to the 9th x squared dx. Now if I'm going to substitute in, I actually need x squared, which is 1/3 du dx. So where I see x squared, I'm going to write this. So I've got I'll put the third out the front. U to the 9th du dx dx. Well, that is 1/3 the integral of u to the 9th du, 1/3 u to the 10th over 10, so it's actually 1/30. Or, what was u? This. X cubed plus 7 to the 10th on 30 plus constant. If you want to check if you're right, you differentiate this one. You're going to get 10 times the brackets to the 9th times 3x squared. Divided by 30 cancels out the 30. So that works. If you prefer, you can write this slightly differently. So I have integral of x squared, x cubed plus 7 to the 9th dx. You can write it slightly differently to do the substitution. Let u equal x cubed plus 7. du is 3x squared dx. Actually, Ryan's probably comfortable with that because we've done that. If I go du dx, then we're going to go, I want to replace dx with du, cross multiply. du over 3x squared is dx. And then you can substitute this as u to the 9th. I've got dx, it's going to be x squared times du over 3x squared, which gives me what I had before. So it depends how your brain works. And if you want brain, you can just go du is 3x squared dx. That's the sort of thing we did when we did separable differential equations. You can choose how you want to write it. I'll probably vary which way I do it because I'm comfortable with both. And when you get good at it and you're comfortable with the substitution, you can go from this straight to here if you want to. You can go from this, go, oh, I'm doing this, it's going to be that. Straight to here. You don't have to write all these lines in between.